This is question 4 in exercise 3.6 in text and test 4 new edition. In the given model of a ramp, ABCD is a horizontal rectangle and ADEF is a vertical rectangle. We have defined the angle ABF, the length of the line AC, and the angle ACF. We have to give each of the answers correct to one decimal place. So, with this, we're going to break all of our problems down into most likely several different triangles. And because we're being told that these are rectangles, so AFED and ABCD are going to be, they're going to have right angles at their corners, which means that their diagonals are going to be the hypotenuse of triangles formed, and we can use that to our advantage. We'll start off by trying to find the angle ABF. ABF is the angle marked over on the right at B, just down there. And in order to figure that out, we're going to use one of the trigonometric ratios, because that is a corner in a right angle triangle. And you can see the right angle is marked just on the left there. So if we call this angle B, we can say that, part 1, the tan of B is equal to 9 over 27, which means B is equal to tan inverse of 9 over 27. So B is going to be equal to, now the inverse tan of 9 over 27 is 18.434,94882. But we were told to give all of our answers correct to one decimal place. So the angle ABF is going to be approximately equal to 18.4 degrees, like that. So that's the first part of that. Now for part 2, the length of the line AC. Well, the line AC is the hypotenuse in the right angle triangle ABC, because as we were told before, ABCD is a horizontal rectangle, which means the corners are going to meet at right angles. So we can use Pythagoras' theorem for this. So we can say that the line AC squared is equal to 27 squared plus 17 squared. 27 squared is 729. And 17 squared is 289. So the sum of them is going to be 1018, which means that AC is going to be equal to root 1018, which is equal to 31.90611,227. Which means that the line AC is approximately equal to 31.9 centimeters. Just like that. Now for the last part, part 3, we're asked to find the measure of the angle ACF. So ACF is a right angle triangle as well, because we have to remember that there's a right angle here which saying that the rectangle on the bottom is at a right angle to the rectangle going up the side. So ACF is a right angle triangle. We don't have the length of the hypotenuse in that triangle, but we do have the height over here, it's 9 centimeters, and we just figured out the length of the line that runs along the bottom of it is 31.9. So what we can say is that the tan, and we'll call the angle C just for the sake of this, so the tan of C is equal to opposite over adjacent, which is 9 over 31.9. Now from there, we can get the angle C. It's going to be equal to tan inverse of 9 over 31. So 9 over 31.9. Which means that's going to be equal to 15.7554396, which means that the angle ACF is approximately equal to 15.7 8 degrees. And that is that.